All right, so January 2022, question number 3, it says, the box below contain the names of 5 quadrilaterals. Choose the name of one quadrilateral from the box that best complete each statement. Statement number 1 says has no line of symmetry and has rotational symmetry of order 1. Now, a line of symmetry is a line that divides your shape into 2 identical halves. In other words, if you fold your shape along the line of symmetry, it will fold exactly onto itself. All right, now the trapezium, to the best of my knowledge, depending on the trapezium has no line of symmetry. Remember, there are 2 types of trapezium. You could have a trapezium that looks like this, maybe more than 2, but just argument's sake. This is sort of like a right angle trapezium. And there's something called an isosceles trapezium, where the left side and the right side are equal. And if you had continued the shape, you would have gotten a trapezium. Now, the isosceles trapezium would have a line of symmetry. If you fold along that line, the shape would fold exactly onto itself. But the trapezium above has no line of symmetry. So since they didn't say isosceles triangle, I'm going to go with trapezium here. So a trapezium has no line of symmetry and it has a rotational symmetry of order 1. Now, rotational symmetry has to do with turning the shape. And turning the shape, let us say, through a 360-degree turn. If in the course of turning the shape sort of like lands back onto itself, you understand? We say that the shape has a rotational line, sorry, a rotational symmetry. We say that the shape has a rotational symmetry. Now, the amount of the time in the turn that it lands onto itself is the order of the rotational symmetry. So if in turning it through 360 degrees, the shape lands back onto itself 3 times, we say that the shape has a rotational symmetry of order 3. So for example, let's have a look at, let us say, an equilateral triangle, for argument's sake. If I spin this shape through 60 degrees, it's going to land back on itself. And if I spin it another 60 degrees, it's going to land back on itself. Every 60 degrees, is it 60? I can't even tell. Let's say for argument's sake, every 60 degrees, it lands back on it. Let me not use an isosceles triangle. Talking foolishness. Let us say a rectangle. It's a good one. Now, you see the rectangle? If you turn it through 180 degrees, it lands back onto itself. And if you turn it another 180 degrees, it lands back onto itself. So it has a rotational symmetry of order 2, because 2 times in a 360-degree turn, it lands back onto itself. This says as exactly 2 lines of symmetry and 4 right angles. I'm going to go here with a rectangle. All right, I think a rectangle is up there. I think the part I had problems with was this part. This says has no line of symmetry, has 1 line of symmetry, but no rotational symmetry. The only other shape I could think of here is the kite. But the problem I had with it is because I thought that every shape had a rotational symmetry of at least order 1. But those would be my 3 answers. I could be right or could be wrong. All right, I know I'm definitely correct about the middle one. It's the first and the last one I'm a little bit hesitant about. B. All right, B says the diagram below shows 4 straight lines, 2 of which are parallel. So obviously the parallel lines are indicated by the arrows, and the other 2 lines which are not parallel, they are called transversals. We're asked to determine the value of Q and R. We're asked to determine the value of Q and R. In that order, determine the value of Q and R. All right, well, R is easy. All right, it's Q that is the issue. All right, no, so all right, here's how we're going to find Q. I'm going to call this angle theta, and I'm going to say to the examiner that theta is equal to 54 degrees, their corresponding angles. Theta is equal to 54 degrees, their corresponding angles. Now, theta and Q are angles on a straight line. So I'm going to say that Q is equal to what? 180 minus theta, which is 180 minus 54 degrees. And this would make it what? 100 and what? 26 degrees. There are angles on a straight line. There are angles on a straight line. All right, so I have Q. R, it's easy. I can see that R is equal to 54 degrees. I'm gonna write it over. R is equal to 54 degrees. They're vertically opposite angles. All right, so I have R and I have Q. Let's turn the page. Next, we're asked to give a geometrical reason why the angle P is equal to 71 degrees. All right, let's look back at it. All right, we should be able to see clearly that the angle P is equal to 71 degrees because the 2 angles are alternate angles. Now, alternate angles are sometimes called Z angles, and Z angles are equal, alternate angles are equal, and alternate angles are formed when the parallel lines and the transversal are used to write a Z. So the angle P is equal to 71 degrees because they are alternate angles. Stay with me. C says the diagram below shows triangle X double prime, Y double prime, Z double prime, and sorry, triangle X prime, Y prime, Z prime, and X double prime, Y double prime, Z double prime, drawn on a square grid. Next, triangle X prime, Y prime, R prime is the image of triangle X, Y, Z after an enlargement of a scale factor 2 with center 5, 1. Wow, this is interesting. The center of enlargement is 5, 1. So this is the center. All right. And the shape we have up there is the image. What we want now is the object. We're to draw triangle, we're to draw triangle X, Y, and Z. Please note that triangle X prime, Y prime, Z prime is the image of triangle X, Y, Z after an enlargement of scale factor 2. Here's what I'm going to use. I'm going to use the fact that whatever is the distance from the center to the image to get to the object, I'm going to halve that distance. Because since the scale factor is 2, the distance from the center to the object is going to be doubled to get to the image. So since I have the image, the distance from the center to the image is going to be halved to get to the object. So from the center to Z prime, this is what? 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So this is 8 left and what? 2 up. Say with me. This is 8 left and 2 up. If I half that, it's going to be 4 left and 1 up. So 1, 2, 3, 4 left, 1 up. This is the point Z. All right. Now after that, I know I can easily draw the rest of it, but let's just go through the motion. The distance now from the center to X prime, 8 left, 1, 2, 3, 4, 5, 6 up, 8 left, 6 up. Half that, 4 left and 3 up. So 4 left, 1, 2, 3 up. This is the new position of, this is where X is. Lastly, to get to Y prime from the center, it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's 6 left, 6 up. Half that, 3 left, 3 up. So 1, 2, 3 left, 1, 2, 3 up. This is the position of Y. We're asked to draw the triangle. Now, triangle X, Y, and Z is the object. Triangle X, Y, and Z is the object. All right, the perfectionist in me is not settling for that. And as I said, the perfectionist in me is not settling for that. I can't help it. All right. So triangle X, Y, Z is the object, and X prime, Y prime, Z prime is the image after an enlargement scale factor what? Center 5, 1 and scale factor 2. Normally the examiner would give you the object and ask you to draw the image. In this case, the examiner gave you the what? The image and asked you to draw the object. So we have done that. Then now we're told that what? Triangle X prime, Y prime, Z prime is mapped onto triangle X double prime, Y double prime, Z double prime by reflection in the line P. We're asked to state the equation of the line P. Now, Y double prime, X double prime, Z double prime is the image of X prime, Y prime, Z prime after reflection in a line that we don't know, the line P. But here's what we know. The mirror line is in the dead middle between the object and the image in a reflection. So this is 1, 2, 3, 4, 5, 6. So if it is 6, the mirror line is going to be 3. It's in the dead middle, so it would be 3 from any one of these. It would be 3 units from y prime or y double prime. 1, 2, 3. This is the mirror line. Now, the mirror line is the line P. It's in the dead middle between the two what shapes. Now, the mirror line is the line P. So this is the line P, and we're asked for the equation of the line P. Now, a vertical line that passes through 2 on the x-axis is the line x is equal to 2. So line P is x is equal to 2. The mirror line, line P, is the line x is equal to 2.